I think we can start now. Great. Okay. So welcome everyone. Thanks for joining us. I'm sure all of us are very excited because we have some very interesting talks lined up today. So the first one is Beyond Ruby 3.0 by none other than Matz himself. And the second talk is on sentiment analysis and Ruby by Ben Greenberg from Vonage. So just to introduce a little bit about our club. So we are NES hackers, and we are based in National University of Singapore in Singapore, Asia. And our aim is to spread the hacker culture in Singapore, which is the culture of tinkering around with things for fun. And we believe that it's because hacker culture leads to a lot of positive outcomes. It's fun, it's good for innovation, it's good for society. In general, it's good for tech. Yeah. In that way, we organize a lot of events. We organize a lot of workshops, hackathons, and we also organize a lot of technical meetups, one of which is happening right now. So yeah, a little bit about our club. You can check us out on Google. This is the schedule for today. Our first talk is on Beyond Ruby 3.0 by Matz, around an hour long, following which we'll have a break for 5 minutes. And then we'll have our second talk by Ben on sentiment analysis. Great, so we'll get started. Just to introduce Matz, he's the chief designer of the Ruby programming language, as we all know. And Ruby was first released in 1995, and since then it has come a long way. It's quite a popular programming language. And Matz released Ruby 3.0 last Christmas, and the focus was on improving Ruby in terms of performance, concurrency, and type analysis. So a lot of cool stuff, and he has contributed immensely to the open source community and Ruby in general, obviously, leading to the famous adage MINASWAN. Yeah. So I can keep talking about Ruby 3.0, but I think there's no one else better in the world than Matz to talk about it. So yeah, Matz, over to you. I'll stop sharing my screen.
Okay, let me talk about the Beyond Ruby 3. As Ted mentioned, here you go. We have released the Ruby 3 in the last Christmas, and the three major design goals of the Ruby 3.0 is one is the concurrency, and then the second is the performance. And then the third is the Ruby should be more productive. We achieved these goals by adding Raptor and Fivers, and JIT and GC for performance, and to achieve the more productivity, so that we added the RBS and the type graph. So we will, I'll explain them later. But basically the language design is difficult because we have very many constraints, especially the compatibility. But the other goals of the Ruby 3 were the first one is compatibility, the second is the performance, then the third one is to implement the better Ruby language. So let me explain about the compatibility. Almost all 2.x programs should run on 3.0 without any problem. So you don't have to modify your application to migrate to Ruby 3 because the compatibility matters. We had, in the past, we had some kind of the Ruby 1, something we called the Ruby 1.9 tragedy. But we had some incompatibility in Ruby 1.8 from 1.9. To accomplish the encoding support and adding several other features, so that incompatibility was necessary to make a better language, but also made some kind of the tragedy, because back then the Rails was there. The original Ruby on Rails supported Ruby 1.8. Then we released the Ruby 1.9. Then we had to introduce some kind of the incompatibility in 1.9, so that some people kept using the older version for a long time. So that we suffered some kind of the community split for more than 5 years. That is kind of sad things, because we are working on the newer version. We improved the performance. We added many new fantastic features to the language, but some part of the community kept using the older version, so that remained from these new features and improvement. Yeah, we had some kind of a similar situation for other languages, like Python 3 and the PHP 6 and then the ECMAScript 4. The Python 3 introduced some kind of the backward incompatible changes, so that many in the Python community, many kept using older version Python 2 for long years, more than 10 years. And the core developer of the PHP language started the project named PHP 6, but these changes designed in the PHP 6 was too drastic, and community did not want that kind of the change because it breaks so many code. So the project PHP 6 was canceled, and the project PHP 7 was restarted from the PHP 5. The similar thing happened in the ECMAScript 4. The ECMAScript 4 was too drastic, and the project was canceled. Then the core team started designing the ECMAScript 5 out of the ECMAScript 3. So language designers, like including me, often make mistakes. So that we want to fix those mistakes if we have chances. But the major version upgrade, there seems to be a good chance to fix those problems. But we suffer some kind of sometimes those incompatible ways. But those languages are the result of these kind of the changes that breaks in many code. Probably major version upgrade are different from apps to languages. The applications can be upgraded, sometimes in the incompatible way, because humans are flexible. So that if your applications changes user interfaces a little bit, but the design of the button changed, the design of the menu order is changed. That's okay most of the time. Or maybe your Twitter designs, the Twitter design has changed. Probably you're okay, but if your programming language has changed, so that your application do not follow that change automatically, so that you have to upgrade your application to migrate to the newer version. So that's a big difference. Even though programmers love new things, but and major version is that seems to be a good chance for the major change, but maybe it is great chance to break your code. So that's good things. But if I always tempted to make the incredible change all the time, but I have to control myself to not to break the language, not to break your application, because compatibility matters. That's the lessons we learned in the past. So that we have to make progress without breaking the past, and we should keep compatibility. We try to keep full compatibility, so that we added new features to the Ruby 3 language, but we've done that, keeping compatibility, except for a few bug fixes. Some programs can rely on the buggy behavior. That we can't help it, but we try to minimize the impact of the change. The second one is performance. Performance matter. I told you we suffered Ruby 1.9 tragedy, and more than 5 years of the community split. But similar things happened in Python. The Python 3 problem suffered more than 10 years. The 5 years to 10 years. We are a little bit better in that case. But the difference is we had the new virtual machine to 1.9. We added new virtual machine to 1.9, and it runs far faster than 1.8. But yeah, even though you have to migrate the application to the 1.9, but if you pay the price of the migration, but your application runs several times faster. So that makes the community, the programmers, motivated to migrate and pay the price. In that sense, performance matters very much for the language. So that's the reason we introduced the JIT compiler to Ruby 2.6, and then improved it year by year. The JIT stands for the just-in-time compiler, so that it dynamically generates native code. We added something named the MJIT since Ruby 2.6 to achievement of Ruby 3.3. The Ruby 3 runs 3 times faster in some benchmarks compared to the Ruby 2.0. The major benchmark is the OptiCalot, which is the Nintendo NES emulator, Nintendo Entertainment System emulator. So that we counted the frame by second on the emulator. So the Ruby 2.0 runs the 20 frame per second. It's too slow to play the game. But Ruby 3 runs 60 frames per second, which is pretty runnable. Yeah. I have to mention this, and the JRuby runs the 120 frames per second, so that's much faster. And the Truffle Ruby runs even faster. But we are catching up. The standard C Ruby is catching up. But unfortunately, the JIT compiler does not improve the Rails performance that much. So that as of Ruby 3.0, the Rails application runs as fast as with JIT and without JIT. it's mostly similar performance, but we are working on it. We are improving. So that let me talk about it later. So that then concurrency. I started development, Ruby development in 1993, the 2 years before the release. But back then, the computers only had one core per computer, one core per machines in 1993. But these days, we have dual core, octa core, 64 cores in the one machine. So that use in general, present day, we use more core. Our software runs faster. The concurrency is a key, but many people complain about our GALE, giant interpreter lock, because of our virtual machine is not thread safe, and many C libraries are not thread safe. So that to avoid, the accidental crash, so that we have to protect our, virtual machine from the access the share data via the threads. Some people complain about the GALE, so that basically only one thread can run the virtual machine. But by tweaking the source code, you can easily remove the GALE from the Ruby implementation. And probably once you create the threads, your program will crash. Unless you have to carefully lock every object. The another option is the fine grain mutual lock. But, in the past, some students in the University of Tokyo try to implement the fine grain lock for the Ruby. And so they prepare a lock for every object. And then when you access to the object, the virtual machine, the threads should obtain the lock. And after accessing this, the thread release those kind of the object locks. And it worked, but it slows down the virtual machine significantly because the lock and unlock has cost. And fine grain lock use the multi-cores, but it slows down your application significantly. That's not good. The thread safe runtime is pretty hard, especially for existing language. So our idea is to add new concurrency entities to the language. One is the async fiber. The second is the Raptor. Async fiber is for IO heavy tasks. Then we have to provide something like the async and await in other languages, like PHP, Python, and Node.js. In Ruby 3, we implement async IO with fibers. We use fibers so that we don't have to use new keywords like async and await. We don't have to care about the promises, or those fibers switch contexts and on IO operations. So that you need to specify a scheduler for the fibers. But once you specify the scheduler, async fiber does multiply the IO operation. So that it does not use the multi-core, but since it's faster and but in context switching, so that result the faster performance. For example, the Falcon is the application server for Ruby, similar to the Unicorn and Puma. And unlike the Unicorn is use processes to multiplexing IO operations, and Puma use the threads to multiplexing the IO operations. And the Falcon use fibers to provide the multiplexing IO multiplications. But And then since the context switch of the fiber is more lightweight than the processes and the threads, the Falcons has a chance to run faster, your application faster. How can we use the multi-cores in Ruby for CPU intensive tasks? That's where we provide the Ractor. Ractor stands for the Ruby actor. It used to be called as a guild, but as we implemented the entities, our design has changed, leaning towards the actor, so that we changed the name as a Ruby actor. The other reason of the renaming was some applications, especially in the gaming industry, use the class named guilds. Anyway, it's designed for the CPU intensive tasks. So the Ractors are basically the isolated object spaces that communicate via sort of channels. So that we don't have any shared objects, unless some otherwise than some exceptions. The one exception is the immutable objects, numbers, symbols. Those immutable objects can be shared. The second one is a recursively frozen object. The frozen strings is okay. Frozen array is okay if every entries are frozen recursively. And then the last one is the very important exceptions. We share the class and the modules, but in Ruby, the classes and modules are mutable. And then we have to, the virtual machines performs the lock and unlock between the class access. For example, the changing the constants of the module and classes. Or when you define the method to the class and modules, we have to perform the locks, even between the Ractors. So not that if you use the meta programming or the modifying the class and the modules from the multiple Ractors, that would slows down the application a lot. So basically, the defining class, defining methods should be done in the main Ractors. And then those classes and the modules should not be attached in principle from the child Ractor. So that we don't have any guilds between Ractors, so that means that we can utilize the multi-cores. Okay, this is the very silly example of the Talai benchmark. So that the first one is the sequential invocation of the Talai function. The second one, the parallel version, is we create the 4 Ractors and run try functions in the Ractors, so that we introduce the 4 try function calls in parallel. But under the current implementation, it runs the 3 point something times faster. That is very silly example, but it has shown us some kind of the possibility of utilize the multi-cores using Ractors. So Ruby 3.0 should be better as a language. So the better error bug finding. So the year 2010s and then later, the age of static typings. the popular language like Go, Rust, Swift, and maybe Kotlin, Scala, those programming languages are static type programming languages. But those languages are pretty popular, and even dynamic programming language like a PHP, Python, TypeScript introduced the type declaration in the language. So that in last 10 years or something, so that everyone goes static typing. So that, shall we? I don't think so. That we don't want declarations. We want more precise checks, of course, so that we like the benefit of static typing. Yeah, we are not, I'm not stubborn enough to deny the benefit of the static typing, so that they have merits. But at the same times, so that we don't want declarations. We want to detect error earlier, and we want code completions, more precise documentations, even static type checks. So that to provide those kind of benefit, we introduced the Ruby signatures and type prof and the steep and the solve type checkers like a steep and solve it. Ruby signatures stand for the like a d.ts counterpart in Ruby. This is the RBS, which is the language. This describes the class foo in the static types. And the Ruby 3 ships with the RBS Ruby signature for the core libraries, core classes, core methods. And then, those information can be used as the type checkers, provide the better ID, the better code completions, or maybe type signature pops up in the IDE like a VS Code and sometimes Vim, Emacs, or something like that. And then at the moment, we have the steep. Steep is the static type checkers. Steep plugin for the VS Code, which provide the information pop up when you write the Ruby code. So that we are starting improving the environment. The type prof is the different tool. It does the naive type checks and the RBS generation for your applications. For example, this is the kind of silly Ruby applications that we have. We define the class foo and the method foo and the bars and the generating the foo object and the cause of foo method or something like that. So then the type prof does the something named abstract interpretations that traces the code graph of your applications, then generate the Ruby signatures. Class foo has method foo that takes integer and returns integers, something like that. Not that the method bar of the class foo has an error in it. So the Ruby signature ignores those methods with errors. We want even, for Ruby 3, we want even better Ruby, so that we added several new syntax. For example, the pattern matching and the numbered parameters. We added the pattern matching in 2.7 like this, so that we can add the searches, the JSON data, and the person named Alice, whose son is named Bob, and take the age of it or something like that. And we added the one-line pattern matching. Like you can use it as a right-hand side assignment, or you can use it as the multi-assignment, and the object decomposition. And the number of block parameters can be like this. Then you don't have to declare this very the block parameters. So that for very simple the blocks, you can write it very precisely. This is Ruby 3.0. So that beyond Ruby 3.0, what will happen? we seek for the completion. Some new features may be buggy, we admit, so that we are working on it, fixing the many bugs, especially for Raptors. And we need improvement to the many features we added in the 3.0. And we are improving on the performance so that people trust much more benchmarks. Now, for the blogging, the measuring performance of the Ruby applications, the measuring Ruby performance by benchmarking Fibonacci or something like that. That's silly. But we admit reputation is formed by micro benchmarks. Unfortunately, it's the Ruby is fast enough for the very big application, web applications, but Fibonacci benchmarks or maybe word count, silly. But okay, we will we improve the performance anyway, even for micro benchmarks. That's the reason we working on the beta jet. So probably after Ruby 3.0, we have to provide the multi-layer jet. The current MJet is kind of heavyweight. It invokes the C compiler, GCC or Clang, and that's heavyweight. So that we are working on the lightweight jet. Probably it will be YJet from the Shopify hired several engineers to implement the YJet jet compiler for Ruby language, or Meal, which is the another lightweight jet layer. So that we are measuring it, we are challenging it. So that maybe, I don't know, but maybe in the near future, so we are going to add some kind of the lightweight JIT compiler to improve the performance, even for the Rails application, and especially the micro benchmarks. And the Raptor performance is not satisfiable for most of us, so that we are working on improving the performance, and we want to reduce the memory consumption of the Raptors, so that we can allocate millions of Raptors from the Ruby programs. And we have to working on the supporting tools like a SolarGlove, which is the language server protocol server, and Sobe is the static type checkers. The Rubocop is the linter, and better tools enables better user experiences for the programmers. So that we emphasize on the language improvement. I mean the tool improvement rather than the language improvement after Ruby 3.0. We need more tools like type checkers, formatters, language server protocols, tools, the performance tuning, debuggers, the many things. Then, this is my plan for the beyond Ruby 3.0, but I have some kind of silly idea, which is named the static barrier. Some dynamic aspect will be prohibited beyond this barrier. I mean, the Ruby is pretty flexible. The metaprogramming, and you can define the class and the monkey patching, and you can reconfigure the class very heavily. But that kind of the dynamic aspect hinders the performance improvement. So that we might declare the static barrier. From now on, Ruby will be static. But maybe the method definition it will be prohibited. The class definition will be prohibited, or eval, or maybe prohibited after this barrier or something like that. In that kind of the barrier, we can heavily optimize the performance of the Ruby language. And this is kind of a silly idea. And yeah, I gave a presentation of those kind of silly ideas in the past, and maybe half of them are realized. So that this is still the idea. But with this idea, this static barrier idea, JIT compiler can be more efficient. Anyway, we will keep moving forward so that we will improve the language to create a better world. And we provide a better Ruby language, and you do create the better applications or better web application, better tools, better something to create a better world. So that you create a better world. And this is my presentation, and thank you.
Okay, great. Thank you, Matz. A lot of cool stuff. Yeah, especially the part on type analysis for me. Yeah, I've been using Ruby for a while personally. I use Rails a lot to prop up websites. So really cool to see all the new things which are happening in Ruby 3. Yeah. Anyway, we'll be opening the floor for questions. Everyone, if you have questions, you can just put it on the Zoom chat and I'll read it out to Matz. So yeah, any questions?
I'm looking at that.
Okay, so Ranes asks that there are a lot of new programming languages and new features coming out from all these programming languages. So do you have some kind of system to keep track of all these new languages and features for inspiration to be so?
Well, in general, I'm a language geek, so that I'm very big fan of the programming language in general. So that I love mostly all programming languages. So that many languages, especially the modern programming language, the source of my inspirations. Like Haskell is one of them, OCaml is one of them, and even newer ones like Elixir and yeah, Clojure. The source of ideas.
Okay. Okay. Thank you, Matt. Are there any other questions? If not, I have a few to ask as well. Okay. So another question is that Microsoft Azure stopped using Ruby in their cloud functions. Do you know why? Or is there any pressure on them to bring it back? I'm not sure if you know.
I don't know about the Microsoft things.
Okay. Okay.
Yeah, in general, the bigger company, bigger enterprise companies don't like Ruby that much. So the Google is very slow to adapt the Ruby in the GCP, and yeah, the Amazon was very slow to adapt the Ruby for their their the serverless environment.
Yeah.
And Microsoft is very slow to adapt the Ruby in their the Azure environment. So that as someone commented, wrote in the comments, so that smaller organization tends to love the flexible language like Ruby, and a bigger organization like the more serious programming language, enterprise programming languages in Java, C#, and sometimes in Python, sometimes lots of Python. Yeah.
Okay. Okay. Great. So another question by Christopher Lozinski is that he read that memory is a limitation in Ruby, and can each factor now allocate memory in Ruby?
Yeah. Under the current implementations, Raptor use the native threads, so that when you create the one Raptor, the runtime creates the one native thread corresponding to the Raptor. So that means that in the Linux system, at least, creating one native threads use the 4 meg of memory for the stack. That means that if you allocate the thousands Raptors, so that you consume the 4 gigs of memory, probably your system will crash. But yeah, we are working on it so that in the future, so that we separate the native threads and the Raptor implementations, so that maybe we create native threads of the number of the cores, then we work those cores work steals from the idle reactors or something like that, like a Go's groupings.
Okay, cool. Yeah, thanks, Matz. So another question by Wilchago Cook is, can you speak to issues around math precision in Ruby? So what do you think might be a way to improve math precision in Ruby programming? Yeah.
What precision?
Math precision. So mathematics precision.
Yeah. I'm not really good at the mathematics in general, so that I personally need help from the community, so that when some kind of the mathematical things is proposed for the our issue trackers, so that people from the community helps me to make decisions, so that I myself is now really good at some kind of the matrix operation or something like that. So that, yeah, I was very good at computer science or the algorithms, but not really as a numerical computations. Yeah, I confess. But so that if you're willing to help me, so that we welcome you. Especially the main discussion of the the mathematical things or non-mathematical things is held in our issue trackers bugs.rubylang.org, so that if you can disclose your opinion at that site, so that we welcome you. And yeah, once you have some kind of you made some contributions to the core, so that we welcome you as a core developers, one of the core developers.
Okay, great. Thanks, Matz. Yeah, I'm not sure if you're willing to take more questions, but another question by Harish is, why do you think Rails and Ruby are so synonymous? So what is the combination? What is about the combination of Rails and Ruby that has really bumped up the usage of Ruby in the world?
The Ruby comes first, and then the Rails runs to some kind of the principle from Ruby, and and crystallize those kind of the big principle into the Rails doctrine or something like that. Then, so in that sense, so that we share similar design principles, and as a result, so that I had been working for the smaller organizations, like the company of the 50 or less for a long time, and the DHH is designed Ruby on Rails originally for the Basecamp, which is the organization less than 100 for a long time. So that as a result, those Ruby and Ruby on Rails might be optimal for the smaller organizations. It does not mean that it's useless for the bigger organizations, but smaller teams can be more productive. So that maybe for the bigger organizations, your application can be the combinations of the smaller applications, kind of similar to microservices.
Okay, cool. So Julius asks an interesting question. What is a programming language besides Ruby that you like the most? And is there a programming language that you like the least?
I like, so I have to define the like before. The most used programming language is C. I write Ruby in C and Ruby, and so I'm very fluent in C, but most liked, probably I like Lisp the best, because I learned the Lisp a lot before I designed Ruby. So the Ruby has the influence from the Lisp language a lot, and Smalltalk.
Yeah.
Yeah, I liked, what's the language I liked least? I don't know, some aspect of the PHP and the JavaScript.
Mm.
But both language has very good aspect as well. But I like those good aspects. For example, the JavaScript has very similar to the language named Scheme, which is the Lisp dialect, and which I love. And PHP has very nifty features, especially in the object-oriented programming. But its appearance and the syntax and the function structure is not appealing. But yeah, those languages are okay.
Okay. Okay, thanks, Matz. So Alyssa asks, what's the most fun part of your role as a language designer in Ruby?
Oh, for most of the people, Ruby is as it is. The Ruby is the things you learn, you study, and you use. But for me, Ruby is some kind of the materials we are working on. Yeah, unlike the very early stage of the development, I have more and more constraints, like a performance matters and the compatibility matters or something like that. But still, the Ruby is for me, Ruby is the material I design so that I can change the language. I can enhance the language. So that's a very interesting part of the being language designer.
Yeah.
I have different role from the most of the Ruby users.
Yeah. Yeah, pretty cool stuff. I think it's, yeah, I cannot imagine working on Ruby myself, but it really sounds very interesting to be able to decide the course of the language. Yeah. So Shuad asks, what resources do you recommend in general for individuals interested to start contributing to Ruby dev?
If you have some kind of a specific idea to improve the language, so that, yeah, that's okay to work on that kind of the things. But if you don't have any specific domain or features you are working on, look at our issue tracker. So that our issue tracker is full of the proposals and ideas, and some of them can be easily implemented so that you can work on it, and then you can raise your hand and I want to try it or something like that. And we welcome those kind of the contributions. Or if you want to propose new ideas, maybe we consider that, and maybe I have to say no, or maybe I can say yes or something. But at least you can try, and then you can learn how to contribute to the Ruby itself. So that is very, I believe the fancy experience.
Okay. Okay, great. Thanks. I think there are a couple other questions. These are more general questions, not related particularly to Ruby in a technical sense. So Benjamin asks, do you have any general advice for computing students?
Yeah. So that take your course seriously, because as a programmer, so that everyone tries. There are many competitors. There are many other programmers. But you have to, how do I say, differentiate yourself. You have to compete to the others. So that your knowledge of the computer science may be the key for the differentiation, or maybe you can have the other field of the interest, so that having the knowledge of the programming and having a skill of the programming, having knowledge of the other field, to combine it so that you can differentiate yourself to from the competitors, like other programmers. For example, I have the very deep interest in the love for the programming language in general. But the very few people try to create their own programming language. But I have that kind of motivations, and I had that kind of motivation for a long time. But because I first feel I wanted to create my own programming language when I was 17, but back then I have no knowledge, so that I couldn't. But 10 years later, I created my programming language, so that it took me 10 years to create my own programming language. Then it took me 10 more years to be usable, yeah, Ruby became a thing.
Yeah.
It took very long time, but that kind of the motivations, make me, Matz, the programmer, so that that is, the key of my success. What you might call it.
Okay. Thanks, Matz. Just I think a couple last questions, and then we can close the floor. Since I know you have to go take care of your kids as well. Yeah. So Luke asks, what other single language should a Rubyist learn to write better than Ruby?
I don't know. If you're a Rails programmer, so that's okay to run Ruby. But if you want to go deeper, the knowledge of the Lisp language, Smalltalk language, and maybe Haskell, and probably Python, maybe good language to learn. Because the Ruby and Python has a similar positions, but for some fields like artificial intelligence or the machine learning, so the Python has better libraries and a bigger community, so that you can learn those kind of things from the Python community. And yeah, Haskell, Lisp, Smalltalks, and the OCaml, those language has different ideas that you can open up the eyes to new ideas.
Okay, great. Thanks, Matz. Just one last question by Christopher, then I have one question to ask, and then so Christopher asks, any chance of porting Ruby to new platforms like Calgary or Parallax?
At the moment, I have zero knowledge of the Calgary and Parallax, so that I don't know. I can say maybe at most.
Okay.
But the Ruby was originally created for the Sun OS from the Spark stations, but it's ported to the many operating systems, including Android and iOS. So that maybe it's not that difficult to migrate them to the new platforms.
Okay, cool, thanks. So, okay, just to wrap up the entire session, my one question is that, at least in my personal experience, I tend to use Ruby only in conjunction with Rails. And as you mentioned, Python supposedly has a better ecosystem for applications like AI and machine learning. So I was wondering, at least in your opinion, do you think Ruby will ever reach a stage where it can be used for applications beyond the ones it currently serves effectively, like machine learning research, AI?
Since it's not technical, so that it's difficult for me to answer that question correctly. But some teams like SciRuby teams was working on the science, the Ruby libraries and the frameworks for the scientific computational fields. And we have some libraries like Nmatrix and Kumo library for the numerical calculations, so that maybe in the future, so that Ruby can be things in those fields as well. But at the moment, it's very tough to say from the right answer.
Okay.
It's very difficult to predict the future.
Yeah. Okay.
But when we introduce the the performance improvement, the popularity of the language maybe changed in the future, so that I believe there is some chances to spread the application field of the Ruby language.
Okay, great. Okay, I think that ends the Q&A. Thanks so much, Matz.
Yeah, thank you.
Thanks for the presentation. And I think a lot of people want to send our appreciation for Ruby as well and for working on it as a language. It's one of my favorite languages.
Thank you.
And I know the idea behind it is that it's a language designed for humans, not for machines. And to me, it gives a very good balance between a object-oriented language and a scripting language, and it makes programming productive to me, and really appreciate that. We're also really humbled that you came down for a talk and to share with so many people. So yeah, that's it. Thank you so much again.
Thank you. I appreciate for the attendance. So thank you.
Okay, bye-bye. I'm not sure if you'll stay on or you'll
I'm staying and listening to the next time.
Okay, great. Okay, in that case, let me share my screen. Okay. Okay, so, thanks everyone. After hearing from Matz, we are going to have our second talk, which is on sentiment analysis and Ruby. And it's by Ben Greenberg, who's a second career developer who previously spent a decade in fields of adult education, community organizing, and nonprofit management. Ben's story is actually very interesting. He switched careers to programming only 4 years ago, which is really recent in my opinion. And currently he's working at Nexmo, the Vonage Communications API platform, but he also experiments with open source projects at night. I mean, he runs this YouTube series called Vonage Gems, and if you watch some episodes of them, you can judge that. I mean, you can understand that Ben is a very heavy Ruby enthusiast. So currently he's living in Tel Aviv, Israel, and quite a great place to live at. So Ben, I think I'll pass the time over to you, and you can start sharing.
Hello, everyone. Let me just share my screen. You can't share a screen without saying you're going to share a screen. So that's very important. I think this is going to do it. Did that share the screen? Can you see that?
Yeah, it works.
Okay, great. I don't use Zoom very often. Hello, everyone. It is so nice to be here this Friday afternoon. And I first of all want to say that when Matt said he's going to stay on for my talk, my heart just skipped a beat. So that's I'm now dealing with that. My Fitbit is like, oh, you're exercising right now. No, I'm actually not exercising right now. I'm just having Matt's in the audience. It was a fantastic talk, Matz. Thank you so much. And I don't think I wouldn't be doing what I'm doing if you didn't write the language you wrote. So it's really just a bit of a privilege to be in this space and to be following you in this talk. It's kind of like a bucket list item for me. It's mission accomplished. It's really, really exciting. And when you said, when someone asked you how to differentiate yourself, and one of the things you said was finding something else you're interested in and finding the way to synthesize that with computer science. That was a really interesting point because that resonated deeply with me. That's something that I strongly believe in. I'm really a bit of a nerd around liberal arts, around human language development, linguistics, anthropology, history, things like that. And so I've always tried and find ways to combine the two interests. So I really appreciated that. So in that spirit, we're going to talk about sentiment analysis and natural language processing. And I hope this talk will be interesting. First of all, just briefly who I am. So as you said, I'm Ben, and I worked for 10 years as a rabbi, which is kind of like a clergy person in the Jewish community. And originally from San Diego, I moved to New York, Boston, Denver, and now live in Tel Aviv here in Israel. And I'm a developer advocate at Vonage, and we're a cloud communications API platform. And I've been there for about 2.5 years, and I've been in software for about 4 or 5 years, give or take, somewhere around there. Although you seem to know exactly how long I've been in, which is awesome. And so what are we going to do today in this talk? We're going to talk about why talking about natural language processing and linguistics matters at all. We're going to spend just a few minutes on sort of like a high-level analysis on what is natural language processing, how does it work, how does sentiment analysis work. We're going to kind of build together a sample app to demonstrate it with Ruby, and then we're going to build it, and then we're going to run it and analyze those results and see what we can gain in some insights into the state of NLP, natural language processing, currently in the field. So that's going to be our objective. But before we can get into some of the more technical aspects of it, the coding aspects, we need to really discuss why this matters at all. And it matters, I think, because we have to make a pretty significant argument that language, the act of a person communicating to another person through the vehicle of language, that's not passive. Language itself is not just an instrument, but language is a conduit for conveying a lot more than just the words you're trying to convey. And I want to give you an example in that from a relatively simple sentence in English and in Hebrew. And I chose Hebrew because it's just the only other language I really know, and it would be inauthentic if I chose language I didn't know. And in this example, I think it's a small example of linguistics. You'll see and get a taste of how language actually shapes the boxes, I would call them, of the way you think. It doesn't reduce what you can think about. It doesn't limit what you can think about, but it contours what you might think about, if that makes sense. So let's say you're standing around the water cooler pre-COVID and you're hanging around the office with your colleagues and you're telling your colleagues that last night I had dinner with someone and it was delicious, right? So in that basic sentence, you identified that you had dinner with a human being, and you identified that the food, the dinner, it was delicious, right? In Hebrew, that sentence in Hebrew is like many other languages in the world. In fact, English is the outlier here, and Hebrew is actually more of the majority of languages in the world. Etmol be'erev achalti arochat erev im mishahu hi teima, right? I ate dinner with a male someone, because Hebrew, like many languages, is a gendered language. Every proper word has a gender to it. So the person, you cannot tell your colleagues that you had dinner with someone without also telling them the gender of the person, or at least the presented gender of the person you had dinner with at that table, right? And the dinner itself is also a gendered language. So dinner is not an it. There is no it in Hebrew, just like in many languages. The word doesn't exist. Dinner is a female word, a meal. And so that she was delicious. I had dinner with a male someone and she was delicious. And that sentence makes perfect sense in Hebrew and many other languages, vast majority of languages in the world, but that sounds utterly ludicrous in English, right? So in English, you get to hide the gender identity of the person that you're talking about, and you get to refer to dinner in a more sort of like abstract way, right? And that has connotations to the way in which you think about the things you think about, right? Like if a knife is male or a fork is feminine, or just to give examples, suddenly those things are different than if they're just abstract nouns, right? So language actually starts shaping some of the ways you think. Another, I think, fantastic example is there are a set of languages in the world that are actually, I would call them, or I don't call them, but linguists call them geocentric languages, right? As opposed to egocentric languages. What does that mean to be a geocentric language? If I'm pointing this way, right? Like I'm talking to, I'm pointing this way. In most languages, including probably the vast majority of languages we speak in this room together, in most languages, I'm pointing at myself, right? I'm saying, look at me. I'm talking, look at me. In a geocentric language, you know what you're doing when you're pointing this way? You're pointing to the cardinal direction behind you. So let's say I'm facing north and I'm pointing this way. I'm actually saying, look south. Look through me, look south, look what direction I'm looking at. And a person who was a native speaker of one of these geocentric languages, a lot of studies have been done on this. If you take that person and move them somewhere, blindfold them, move them somewhere else in the world, and put them in a forest, give them a moment, and they will be able to tell you which way is north, south, east, and west. That's like unbelievable. I don't even know which way is north any day of the moment. Like I have no idea. I don't know what direction I am at all. So like if you were giving directions to somebody and you're an egocentric speaker, you say something like go down the block, turn left and right, and then make another left, right? In a geocentric language, you would say like go north 2 blocks, turn east, and then it's on the northwest corner. To have that sense of spatial like mapping technology in your head basically at all times is like unbelievable. So language is actually a way of understanding the world. And when a language goes away, when a language dies, a whole way of understanding the world dies. So language is actually sort of like a conduit constructor. Language shapes how you think about things. It doesn't totally limit it, but it shapes the way you think about it. So example, in English, you might say it's raining, right? So you turn the word rain and it's now raining. A lot of languages, you would say it is falling rain, right? Can you not imagine that you can also say rain can be raining? Of course you could as a speaker of the other language, but you just don't think that way. Like rain is a thing. Rain doesn't move. It is falling rain because the thing, you get what I'm saying. So there's all different kinds of ways of understanding language, and language shapes a lot of the ways in which we construct our world. So understanding language actually helps us understand, I would say, human society at large. So there's a deep need, a deep drive, and a deep sort of mission to understand human language, understand the ways in which we speak. Because the more we can understand language, the more we can understand each other. And if there's something we can do more today than anything, is to create and foster greater understanding amongst peoples. So the more we can understand each other, the better. And algorithms can help us get there. And what are those algorithms? Well, they're natural language understanding, natural language processing, NLP, NLU, and sentiment analysis. It's particularly the first one, natural language understanding, helps to really programmatically understand what a person, what an author, what a text, what it's actually saying from a programmatic perspective. Where did this all stem from? So I think this all stemmed from, you have to go back now a few decades to Alan Turing, right? And Alan Turing offered a prophecy. Didn't think he was a prophet, but apparently he was. And he said that by the year 2000, you would not be able to imagine the juxtaposition of machine and thinking and see them as at odds with each other. That machine and thinking would be synonymous. That you would look at a machine and say that thinks. Just like I think, so too does a machine think. That was Alan's imagination. It was Alan's prediction that by the year 2000, we would have machines, right? Machines that would be able to think. And what is it to think? I think, what is the think? I think that what is the think is a big leap in that is if you can understand the ridiculousness that is human language. Because human language is so full of contradictions. It's so challenging to understand. It breaks its rules. Every time there is a rule, there's 10 ways to break it, right? So if you can build a machine that can understand that, maybe you can make an argument that machines are somewhere on the road, on the path to thinking. Question is, are we there yet? So that's going to be our objective. So let's look at what we get back from natural language understanding when we run it through the popular services out there. So that sentence we started with, last night I had dinner with someone, it was delicious. That gets broken down into different data points. First, you get a sentiment score on it, right? And the sentiment score is, between -1 to 1, right? So last night I had dinner with someone, the sentiment score there is 97% positive. It's a positive sentiment. You get back to semantic roles in the sentence. Things like the subject of the sentence is an I. The sentence, you see the sentence and the object of the sentence was dinner. The action was have in the past tense, right? You find the key words. Last night, 99% relevance. And dinner followed by that with dinner was 67% relevance. You get the emotional scoring. So it's a majority of a joyful sentence, right? 85% joyful. And you even get categories, which is kind of cool. So what's the top categories here? Food and drink, dinner. That makes sense. It's kind of good scoring. I mean, I think you would agree with me, right? That's pretty accurate. But I also very intentionally offered you a very simple sentence to begin with. And a very simple sentence, clean, it's written basically grammatically correct. I ran Grammarly on it, so I think it's correct. I don't really know, but it's basically grammatically correct. Gets a nice, clean scoring. How does that work? So it works by things like formal grammar, inflectional endings, parts of speech tagging, parsing sentences, sentence boundaries, topic segmentation, etc. And those things are really important because a sentence like police helps dog bite victim can be really different if you say police helps dog bite victim or police helps dog bite victim. On one hand, the police is being an aggressor. On the other hand, the police is being helpful. If the police is helping the dog bite the victim, or the police is helping the dog bite victim. So that makes a big difference. And to train an algorithm to understand where to put the inflectional endings in a sentence can dramatically change the meaning of a sentence, right? So that's radical. So going from the police to be a helper to the police to be an obstacle, or in this case, I guess a hungry police officer, I'm not exactly sure, but it's a really difference there, big difference. One of those primary rules is something called polarity. It's a foundational rule within the study of linguistics, the polarity of something. Polarity is, as the word sounds, the polar, right? The two opposites. So you have to understand the polarity, the sentimentality, the sentiment polarity of a sentence. And I want to run through this with you of 3 examples. And these examples come from Wikipedia, right? So they're vetted by whatever that means. Wikipedia is vetting. So 3 examples from Wikipedia in order of difficulty. The first one, I dislike broken cars. What is the polarity of I dislike broken cars? Well, that one's pretty easy, right? I dislike broken cars. I'm angry. I'm upset. I'm expressing displeasure. I dislike broken cars. Take a different sentence, right? The next sentence we're going to look at is, I'd really, truly love going out in this weather. I'm trying to say that without emotion. It's hard. I'd really, truly love going out in this weather. Now that could be, I'd really, truly love going out in this weather. Or it could be, I'd really, truly love going out in this weather. Which one is it? Is it, that was my sarcastic voice in the first one, if you couldn't get it. Is it sarcasm? Ugh, the weather outside is horrible. It's not a great day. Why would I want to go out in such a thing? Or is it, the weather outside is amazing. It's sunny and shiny and it's a beautiful beach day. Let's go hang out and sit at the beach all day. Where is sarcasm? How do you understand sarcasm in a sentence? Most NLP algorithms can actually process sarcasm. It's pretty cool. That's really hard, by the way. But where is the sarcasm derived from, by the way? How do you understand sarcasm? The primary way to understand sarcasm is in its context, right? So the algorithm has to be able to see the larger textual context and pick up whether this individual segment, this individual sentence, whether it is sarcastic within the larger contextual text sample that it's looking at, which is pretty cool. Let's go even harder. It gets harder. The next sentence I want to show you is this one. I love my mobile, but I would not recommend it to any of my colleagues. What is that? I love my cell phone, but I wouldn't recommend it for you. What do you do there? Either you love this cell phone, it's a great cell phone. I have a Pixel phone. I kind of like it. It works most of the time. But I wouldn't want you to have the Pixel. No, you should have a Samsung Galaxy phone. What does that mean? Like, either you like it or you don't like it. And a sentence like that, either you're expressing happiness with your phone or you're like expressing equivocation, ambivalence maybe. How do you deal with that? Well, the problem with that sentence is it's contradictory. But you know what? Humans are incredibly contradictory. I don't know if that's a surprise to you. That might be a revelation. But we are like a mess of contradictions all the time. We say things that don't make sense all the time. And how are we supposed to train machines, like in Alan Turing's language? How are we supposed to train machines to understand human messiness, human contradiction? That sentence is a legitimate sentence. And that sentence stumps NLP today. You can't get an accurate read on that sentence because it just doesn't make sense. But yet that's a sentence a human might actually say. So we're getting there, but we're not yet fully there. All of that was sort of like, let's say, a bit of a background perspective on really high level. We didn't dive deeply into it, but high level into what is NLP, sort of like what are the rules guiding it, why is it important? But a question we want to address for us is like, what can I do with it? So I think for what I can do with it, something I do every morning, and I may be alone in doing this, and if you do it too, then maybe we can create a club of those who do it. The first thing I do when I wake up in the morning, and maybe this totally seems unfamiliar to any of you, is I look at my phone. I don't know if you do that. Like before I even get out of bed, I look at my phone. I'm sure I'm the only one in the world that does that. And the first thing I do, I look at my phone is I like see what the news headlines are, because I kind of want to know whether I can get up right away in the morning or I should put the covers over me and go back to sleep. Like, is it going to be a disastrous day? Like, is it a day where I can just get up in the morning, make my cappuccino and like start the day and be excited? And I want to know in general, like, how bad is this day going to be? And in the past year, unfortunately, it's been a lot of days of pulling the covers up more tightly and like, ugh, like, can I just sleep through this day already? And so you kind of want to just build an app that gets you to the point and tells you what's the mood of the news. Like, just tell me, like, should I wake up or should I go back to sleep? Like, is this gonna be a bad day or is it gonna be a great day? So that's what I want to do with us. I want to run that through building what's the mood of the news on a topic that I'm interested in, whatever that topic may be. And in 2020 and beginning of 2021, there's a lot of topics that we could center that on. But in general, what's the mood of the news? So we're going to build an app that does this, and it's going to be a WhatsApp kind of app. So WhatsApp app, that sounds a bit funny, but a WhatsApp app. And essentially it'll be a Rails app that runs a WhatsApp server that, a WhatsApp bot, I mean, that accepts a message from a user that is a topic. So I want the mood of the news on whatever topic I want. And then it's going to scour the web for all the headlines on that topic of the day. It's going to send them to IBM Watson for natural language analyzing. So there's three big sort of companies that do this for profit. One of them is IBM Watson. The other one is Microsoft Azure. And the other one is Google Cloud Platform, right? GCP. So I'm choosing Watson. I chose Watson because, and this may be a bit selfish, they have a pretty nice Ruby SDK. And the IBM in general cloud provider services have some nice Ruby support. So that's why I chose it. So I'm building with IBM Watson, and then Vonage, which is of course the company that gives me my monthly paycheck. Vonage will be the WhatsApp provider, sending the message and communicating through the Vonage APIs, right? And this will be all on Rails. Make sense? Okay, cool. So the first thing we want to do is I mentioned IBM Watson. They all have Ruby SDK. They all have a free access tier. They all have good documentation. Those are their links. The slides will be available after, I'm sure. So if you don't have to like worry about where to find it, you can get it after. And then I'm also using a free API called News API, which is a pretty cool API. You can send it a, query params of what you want to search for. You can also give it some other, specific parameters like delimiting params, like dates or other kind of things, ascending order, descending order, whatever. And you could get like a list of news headlines in that topic, either worldwide or by region, things like that. Pretty cool. So I'm using a News API, using Vonage Messages API, which is a multi-channel API. So WhatsApp, Facebook, Viber, SMS, and IBM Watson. The first thing you do, obviously, with a app is you get its gem file. So there's 4 gems I'm putting in here in addition to the standard ones. One is Vonage Rails. I built this gem, so I'm a little partial to it. It's essentially an initializer for the Vonage Ruby SDK for Rails. So it reads your credentials, whether they're in Rails credentials or in .env or what have you. It reads those, and then it automatically creates an initializer folder, a file for you in your Rails app, and gives you a globally available instance of the Vonage SDK you can invoke anywhere. So it kind of like takes a couple of the steps away from you, I guess, makes it a little bit simpler to get up and running. So it wraps the Vonage Ruby SDK, right, as an initializer. And then the News API has Ruby SDK, IBM Watson, as it says, has Ruby SDK, and .env Rails, which was used to manage our environment variables. And then we only going to have 2 routes. That's it, because we don't have any client-side stuff. Like there's no front end to here. Could have built this on Hanami, also could have built it as just a Sinatra app, as a rack app, whatever, but I'm really partial to Rails. Everything is for me is Rails, so I built it on Rails. It's got 2 routes, that's it. 2 post routes, inbound webhooks and status webhooks. Really kind of simple on the routes end. And then we have some environment variables, all those API credentials. Whenever you're working with APIs, there's so many credentials. It's like you have to keep track of all those credentials. So there's the API key from the News API, the Watson credentials, and your Vonage credentials. This is a red alert. I could have refactored this really nicely and put this in like service helpers and model functions. This is a big controller. This is a really big controller. It works. This is a demo proof of concept app, right? So I was less concerned with the clean architecture of it. You can find other examples. I know how to write clean architecture Rails apps. This is not it. This is to get it running and working. So it's a big controller. And I'm sure, you know, any of you who've written Rails are not going to be happy with that, but it is what it is. So I put everything in the controller. I call it news controller, right? And my status webhook route, I essentially just want to deliver a 204 API return value of no content, because when you're working with webhooks are basically a way to keep on getting info back from an API without having to ping for it. So instead of saying like, is there anything new? 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 Every 5 seconds, you can just wait for the API to tell you when there's something new. But a webhook expects to get something back. So the API will keep on sending it to you over and over again until you acknowledge it. Like, yeah, I got it. Thanks. We're good. So that's basically what the 204 is. And that's sort of status updates on all the different APIs. So just letting it know, hey, like we received the message, we're good. And then in addition to that, we move on to the next method, which is the inbound method. So this is when a user sends the WhatsApp message to our WhatsApp bot. This is how we're going to process it. We want to grab 2 values. We want to grab the topic that they sent in, and we want to grab their phone number because we want to reply to them at the end, right? And I would also recommend, in addition to taking this out of the controller, if you're going to do this in any kind of real way, I would also recommend sanitizing the topic, verifying the topic, validating the topic, making sure that a user is not sending something you don't expect. This app is for me. I'm not going to hack myself, so I'm okay. But I would, if I was doing this in any kind of production way, I would do some validations on that, right? And then, so I'm grabbing the topic from the params and grabbing the phone number from the params, and then I'm going to analyze those headlines. And that's a method that we're going to create, and I'm calling analyze headlines, which is going to send in, accept the arguments of a topic and the phone number of the person, right? Pretty relatively straightforward at this point. And then we need to actually build analyze headlines. This is not meant to be read. It's a lot there. It's small. I recognize that. It's small font. But essentially what we're doing is we are instantiating an instance of the IBM Watson API SDK. We need 2 things from the IBM Watson SDK. We need, let's see if I can make that actually a little bigger. We need the authenticator, which generates the token for the for credentialing, and then we also need an instance of the NLU class from the SDK. So we pass in the authenticator token into that instance of the NLU class, which is namespace IBM Watson Natural Language Understanding v1. And then we also, so I'm on the free tier of IBM Watson, and anytime you have the free tier, you're limited to the gateway URL of where you were in the world when you created it. So I happen to have been at a conference in, I think I was in Amsterdam at that time, and I created my IBM Watson account. So now I'm forevermore attached to London, their London gateway. I'm sure, I don't know, when you live in Israel, there is really no good gateway for you. You either attach to Singapore or London. And if the API is not good, then you're attached to New York or San Francisco. So I'm always somewhere between Singapore and London anyways. So that's just the nature of life of being in the Middle East. And so I'm attached to the London gateway, so I have to specify that. And then I said, I want to get back a response on this text that I'm sending in. And the response I want everything. Remember I showed you the return that you get back on a sentence from the NLU, that simple sentence in the beginning. I want the entities. I want those keywords. I want the sentiment. I want the categories. I want the concepts. I want the semantic rules. I want the emotion. I want it all, right? Give me everything. I'm a big believer in when you're asking for an API for something, just get as much as you can. And then you, as the developer, can filter down what you specifically need in it once you have it, but just get the data. I like getting data. I like more data, the better. And then I output it for myself in JSON so we could see it in the console, Rails console. And as you notice there as well, what I passed into analyze on line 13 is actually another method called get news headlines, because I didn't actually pass in a text. I'm passing in a method which will return the headline, the string of headlines on the topic from the News API. And then finally, we send the WhatsApp message. So at that point, we need to build the get news headline. That's a lot smaller of a method. We basically make an API call to the news API, pass in the topic, which is what the user sent in by WhatsApp. And to me, this is really important. I want to sort it by popularity. And why do I want to do that? Because if I want to know what the mood of the news is, what shapes the mood of the news? What shapes the I guess, the zeitgeist of the day? The more eyeballs on something, like the more people who see something, shapes sort of like the sentiment of the news of that day, right? So if it's an article that only 2 people saw, it doesn't really matter that much in this regard. But if it's an article that 100 million people saw, well, that's going to shape more of sort of the way people are thinking about something. So I want to start sort of in that order. Give me the most popular things and then go down from there, because that's what's shaping the mood of the news, so to speak. And then you get it back from you get it back in an array of items. IBM Watson wants a string, so I just convert it to a string, and then I return that string. Cool. Okay. So that's the get news headlines. And now we have the actual headlines. This last one, you don't need to read it. It's an API call to the Vonage Messages API. The way that we work at Vonage is if an API is not yet in general availability status, if it's still in beta, meaning it's accessible, it's stable relatively, but it's not yet in the GA status, we don't create SDK support for it, because we feel like the SDK should only be supporting GA APIs, like APIs that you know will not change in a radical way. So the Message API, which does the WhatsApp stuff, is in beta status still. So there isn't Ruby SDK functionality for it yet. So we have to actually create the, we invoke net HTTP library, and we create a URI and pass in the credentials and the body, like we build an HTTP request, right? And at the end of the HTTP request, we send back the message to the user that you asked for the mood of the news and the following topic, and here you go. And we send back to them the sentiment of the mood of the news on that topic. And the last thing we need to do is generate a JWT token for the Vonage API, and we can use the Ruby SDK's functionality for that. And then we're ready to give it a go. So that's sort of the structure of the code around it. And at the end of this, I'll give you a link to the GitHub repo. You're definitely welcome to clone it. There's instructions. There's actually even a deploy to Heroku button on it. So you can click the link, deploy to Heroku, and then pass in your API credentials and have like a fully running instance of this without having to do anything really. And you can play with it yourself, and you can see all the code too on your own machine. But let's actually give it a go. So this was sent, I sent this a few days ago by WhatsApp to myself, right? So I created the bot, I instantiated the bot, and I sent in a message. And let's see if I can get this to run. Is it running? There we go. I sent in the message, and the message I sent in is programming. What's the mood of the news on programming? And it's running through all those different APIs. It takes a few seconds. It's running the sentiment analysis, sending me back the message. And we see that the mood of the news on programming for this day, it was only like a short while ago, was positive, right? It was a positive sentiment for the mood of the news on programming with 79% joyfulness. Programming is really joyful, people. That's amazing. We're a joyful community. We have a little bit of other things in there, like 16% of anger, which is really interesting to see. Why is there anger? I would expect, if it's positive overall, to see I would have expected to see a higher number for joy. And it's interesting to me that I see 16% of anger, right? That's very fascinating to me. And then some small numbers here, 1% of disgust, 0.4% of sadness, things like that. When I see that, what I want to do now with us is examine that data, because how do we get there? Everything we said to this point, everything we did is to get to this moment, which is, how smart are these things? I sent in the topic of programming. How smart is it actually running? Like, what's actually happening behind the scenes? These were the headlines. This 11-course bundle will teach you how to build a killer Android app. Wow, that's awesome. Hello world, but how do I start? Making games on your own as an engineer, building e-ink laptop modules, monoliths, and microservices. Upgrade your weekly game night with these modern versions of your favorite board games. A true crime docuseries from Blumhouse to premiere on Epix this May. 3D printing and embroidery. We see some stuff here about Fox Business, look at finances. Plus One Solutions API ensures a whole view of the network's compliance and risk information. Annual results of some company in the shock of COVID-19. All kinds of interesting headlines. That is really not necessarily what I was expecting. And in fact, there were 20 headlines in our sample data. 7 of them I classified when I looked at them were directly related to our topic, which was programming, right? Which meant, and I'm not so great at math, but I can do this, 38.8% of the sample was directly related to the topic that we were interested in. What? That's crazy. That's wild. What does that mean? Like, so I thought I was asking about programming, right? I was actually asking something really different. What I got back was a lot different than what I thought I was asking. Always examine your data. Never take your data for granted. Don't assume. If you assume with your data, you're going to be in trouble. So when we examine that analysis, what we saw, as we mentioned, 80% score of positive, right? And we see there the actual JSON that comes back, the data object that comes back, 79% of joy, fear is at 0.006, anger is at 16%, which is high, right? But maybe now we can start grasping why anger is a little higher than I would have imagined when I first saw those numbers. Because what's really happening here? Well, what's really happening here is we have to look at those concepts. So we said that 38% of our data was actually related to our topic. What were the concepts that were identified? Remember in that sentence where last night I had dinner with someone, it was delicious. The concepts were food and drink and dinner, totally like great and made sense. And we're right on the, how you say, the mark, right? So what were the concepts here? Income, 92%, game, 89%, design, revenue, construction. So what we're starting to see here is that even the topics that were programming related were on the concept or the concepts of the business of programming. And the second you venture into the business of anything, it gets a little more negative. And suddenly the scoring, the emotional scoring goes to 16% of anger. Whoa, that's wild. Because now we're talking about the business of programming. And so there's a little more of the I would say the negativity there a little bit. For some reason, business is a polarizing topic. I don't exactly know why, but it is for some people. And that all brings us back to Alan Turing. So Alan Turing, when he articulated that by the year 2000, you would not be able to imagine the positioning of machine and thinking as contradictory. If we think about what we just looked at together today in this little bit of time we had, and we think about, sort of, did I get what I wanted back? Did I get what I expected back when I sent in the data I sent in? How accurate was it? Were the topics I really imagined them to be? Were the concepts the ones I imagined them to be? And if human language is the barometer by which we can evaluate, and this is, by the way, an assumption I'm making, and it's arguable, and you can argue with me on this, but I'm arguing that human language is the barometer by which we can assess the thinkingness of something, because human language is so odd and an outlier. And if you can understand language, you can understand thinking. And if that is the barometer by how we can understand thinking, how have we reached that point? I would probably argue we haven't. But that's my argument. I would love to hear what you think. Thank you so much for your time. I want to leave you some resources. This book is fantastic by Guy Deutscher, called Through the Language Glass, Why the World Looks Different in Other Languages. It is so fascinating. There's a whole example in there about the color red, which was eye-opening to me. And this might be known by some people. It wasn't known by me until I read this book. And I sat on this idea for so long, how like the stoplight color of red, there's an international body that assigns the colors of stoplights and traffic lights. And in some countries, red is not the same red as in other countries. And it became a whole sort of like, I think this was actually in Japan, if I'm not mistaken, and how red became like what is red in, and maybe in Japan, I'm pretty sure it's Japan, is different than what is red in like Western Europe, for example. And there's a whole conversation about the evolution of color and how's color become different from one place to another place. And that's just so interesting to me. So that's a great book. There's an article, 2011 from the University of Chicago, Polarity. And these are the APIs I mentioned. And the GitHub repo for this app is at the bottom, github.com/nexmo/mood of the news. If you want to try this a little bit, here's a credit for 10 euros of free credit. 10 euros, depending on the day, means more or less, I don't know. But 10 euros of free credit with that code 21KHBPN. And you can go to that link and get an API account that's also unlocked. So when you use that credit, you get out of the sandbox, and you also get 10 euros, which is a lot of money for API calls. Each API call is like fraction of a cent. So it gets you pretty far. Thank you so much. That's my talk.
Great. Thanks so much, Ben. I think we'll open the floor for questions right now. So are there any questions? Feel free to type it in the chat, or if you want to ask it verbally, you can raise hand and I can unmute you. Any questions?
I just awed all of you so much, it's impossible. There's no way. I do that all the time to my family too. They're like, oh, Ben, just stop talking.
If not, I actually have a couple of questions. Okay, so Matt asks, what languages are your customers using to integrate with Vonage APIs?
That's a really good question. It's a question of obviously there's a business interest to analyze that question and get that data in real time. And we track that. We add a little bit of header in our SDKs for an API call from an SDK. We get a sense of like which SDK it's coming from. And I think you would all be happy to know, and I'm happy to know, that in the past few months, the #1 SDK for API calls has been the Ruby SDK, which is a bit surprising based on what Matz had said earlier, right? About corporations using some languages over other languages. But there is a lot of companies. There are a lot of companies out there, a lot of organizations out there who are building with Ruby, particularly in the startup landscape, particularly like, in that sort of like evolving new company space. And there's some huge corporations out there. I don't know if I can name them, but there's some huge corporations out there who their code base is entirely Ruby. And so when they make their API calls, some of them might be famous pizza companies, for example. And so every time they send a message to their customers that your pizza is on its way, that's an API call through the Ruby SDK. And that's a lot of API calls. And so that's pretty cool.
Okay, great. The second question is, it's more related to linguistics. So have you looked at the Sapir-Whorf hypothesis, which talks about how language is related to how we cognitively view the world?
I love that question.
Yeah.
So, wait, finish the question though. I shouldn't have interrupted you.
Yeah, that's a question. Yeah.
It's such a good question. I have looked at that hypothesis a bit, and it's really interesting and fascinating. Whether language determines our worldview or vice versa. So that hypothesis obviously offers its own perspective. There's a lot of competing literature out there in the field of linguistics. And this, and by the way, is probably its talk on of its own, and its entirely own topic that would take hours to discuss. But, there's also, you have to, what's the word for it? Like disaggregate a lot of the biases that were in the beginnings of the studies of linguistics. Linguistics evolved in a very certain cultures that had a lot of set of preconceived biases and notions around other languages and other cultures. Like, for example, the notion that Latin is the highest form of language. I don't know who said that. Latin's an odd language, but like that was a very common thing, and other languages were evaluated against Latin, sort of like Latin. And it's a reason why, like in English, a lot of things are frowned upon the way you speak in English, because it's not Latin grammar. But English is its own grammar, and Latin is its own grammar, and one shouldn't necessarily be held up to the standard of the other one. It's a good question, and this book I recommended, by the way, by Guy Deutscher, delves a lot into that hypothesis, by the way, and sort of and where he lands is that somewhere in the middle, that language doesn't confine the way we view the world, but it boxes the way we view the world. And it's not, you can't get out of your box. You can definitely get out of your box, and you can understand other boxes, but you are definitely in some ways limited by a box you're in. And I think that resonates, at least it resonates with me.
Yeah, really cool stuff. I've actually read the Guy Deutscher paper. Yeah, quite cool stuff.
It's cool, right?
Yeah,
it's really cool. And then there's a whole nother sort of like dimension if you're a speaker of more than one language, right? So if
Yeah,
you're a bilingual
exactly.
speaker,
Yeah.
what box are you in, and what are your boxes? And
Really interesting things to
yeah,
know.
really interesting stuff.
Okay, so moving on, Matt asks, does Vonage see real-time sentiment analysis and other AI initiatives as being supplementary to your current APIs?
Yes, absolutely. So this was built using IBM Watson, right? But only about a year ago, Vonage acquired an Israeli startup called Over AI, a team of about 50 folks. And what they do is this: natural language understanding, sentiment analysis, and that is a product that is an offering called Vonage AI.
Yeah.
It is not. It will be probably generally available by the end of this year. But it's talked about on the website. It is a thing, and it's one of its best use cases in our context. But we're a communications company. One of its best use cases is contact centers. Because if you think about a contact center, so you have like, I don't know if any of you have been in a room, a physical contact center room, and you see these like banks of machines of people sitting, like rows of people answering phone calls, right? And constantly like processing phone calls. And the goal is to get through phone calls as efficiently as possible. If you can offer those contact center employees in the moment, real time, what is the sentiment of the person before they answer the phone call? So before the call gets to them, they already know by interacting with your AI, if they're in a good mood, a bad mood, if they're frustrated, that can help shift the discourse right away. And if you're like me and you're interacting with one of these machines that like press 1 for this, press 2 for this, I'm always frustrated. So I don't know how well it worked for me, but like I guess it would work. But that's a real-time use case and is actually being used in the field now, and that's coming from Vonage AI.
Right. Okay. Great. Thanks. Matt. Oh, sorry. Another question is, what this is more related to sentiment analysis, I think. What big picture steps would you take to build something that can analyze the literary qualities of, say, fiction or poetry, inclusive of sentiment? Yeah.
Oh, that's a hard question, because I think you would have to first say what you mean by literary qualities.
Yeah.
Like you would have to first define what that is, right? And literary qualities can mean a whole lot of different things. Is it the grammatical correctness of the literary text or of the piece of literature you're looking at? Is it the style? Is it some prose that you're looking at? Is it, does the sentiment match the expectation the author is trying to create? So that kind of thing, that's really challenging. And I think you first have to find the scope of what you would say by literary qualities, and then you could start building some solution towards that scope.
Okay. Okay, cool. Matt asks how easy it is to get started with Vonage APIs.
So I'm paid to say it's easy. The real answer though is that it really depends. To get started, it's relatively straightforward. It's not hard. To send your first SMS message, you can do that in like 2 lines of code. It's really pretty straightforward. To start building complex solutions, it gets a little more challenging, but that's like everything. And when you're building some kind of solution, the more complex it is, the more challenging it is. And we're constantly trying to help. So if I can just get on a soapbox for like 1 second, a lot of my work in Vonage is on the SDK side of things. And I spend a lot of my time on the engineering side of like our SDKs. And our SDK team is really devoted to the idea that an SDK has to do a lot more than just make HTTP calls for you. That if all it's doing for you is just making the HTTP calls, it's worthless in some ways. And what an SDK actually needs to do is it needs to create a more like Ruby experience in developing, meaning it's got to be more human. It's got to be more helpful. It has to like abstract away a lot of the complexities for you. And I'm constantly trying to do that. So for example, a couple things I did recently in the Ruby library is I introduced static typing into all the classes using sorbet. And so at this point, when you're building in a real runtime environment, you can get some feedback right away when you're invoking the methods in the SDK. That's helpful, right, as a developer. The second thing I did recently, I just released this last night, is the newest minor release of the SDK incorporates a builder for the voice API. So the voice API is really complex. because you can do synthesized text to speech. You can do, we have a natural language engine in the voice API. So if someone's speaking, you can understand and process that into text. And you can build conference calls and play audio and WebSockets and all other kinds of really complex stuff in the voice API. And that takes you sending these really detailed JSON structures we call NCCOs, the voice API. So what I just released last night in the SDK, the Ruby SDK, is an NCCO builder, which basically you tell it, I want to build this action, and this action, you give it its parameters, and it constructs the body for you. And then all you have to do then is just send that to the API. So we're constantly trying to do things like that because yeah, getting up and running and starting is not so hard. But if you actually want to build things that are robust and have a lot and deal with a lot of edge cases and a lot of like nuance, it can scale and get in complexity really fast.
Yep. Okay, cool. Thanks, Ben. I think one last question, which would be a good wrap up, is what motivated you to switch careers into programming from being a rabbi, which is not something you come across in a lot of people.
What do you mean? That's such a common path.
I mean the switch, like the switch from rabbi to programming.
I'm just joking. It's not that common a path. There's actually several of us in the larger world, and we're all friends. We have like a rabbi's Discord server. It exists. It's a good question. I mean, I've always been a bit of a tech guy. I've always been interested in it. When I was in high school, I started it ended up it's running more than 20 years now at this point, 20 something years. It's the largest hacker conference in San Diego, California. It gets like 800 people. I started that when I was 15 years old. So like this was always like a part of me, and I never did it professionally. And I reached a point in my first career where I was ready for a switch. I was interested I wanted to pursue this. And if any of you are, with a partner, right, or in any kind of like relationship like that, you can't do anything like that without asking permission, because, taking the switch, stopping working, right, training up again, that's a big thing to do. And so I asked my wife for permission, and she said, okay. And I'm like, okay, let's do this. And I did it. And now it's almost 5 years, and it's been fantastic. And I get to like do that thing I loved doing when I was a teenager and a kid, but now I get like I was programming in Perl when I was a kid, but like now I get to do this like for fun, and it's a job, and I never got to do that before. So that was like the big switch for me. I get to like live out that interest that I really had for a long time, and get paid for it, and I get paid to do it in a language that Matz created, which is the best of both worlds. It's amazing. I can't believe I get to work in Ruby all the time. Like, what luck do I have? That's like amazing luck.
Okay. Okay. Thanks, Ben. I think we'll wrap up the session right now. So thanks for the talk. Really interesting motivations, really interesting applications.
Thank you.
To think about in terms of application. Yeah. So I think we'll be wrapping up our Friday Hack session here. Thanks everyone for attending. I think it was a privilege for us to have Matz talk and get such an interesting talk by Ben on how we can do sentiment analysis in Ruby. So if you're interested in these kind of talks, NES Hackers organizes Friday Hacks every week or bi-weekly. So next week we have 2 talks. The first one is on disaster recovery, which is about how do you recover when your database or backend goes down, and how do you prevent data from being wiped. And the second one is on help. I just got hired as a junior dev, which is, and the talk would cover common anxieties that new developers who go into the industry face as they try to navigate getting work done, and probably imposter syndrome. And it's by someone who's currently working at a US startup. Yeah, so thanks everyone for coming. I hope you got to learn a lot about Ruby from Ben and Matz. I got to enjoy the talks a lot. We always look for feedback in our talks on how we could have better organized the talk, or if there are topics you really, really want us to be hosting sometime in the future, you can always put it in the feedback, and we'll try our best. So that's our website, and you can also join our Telegram channel. And any other questions which cannot be addressed through the Telegram channel, you can always contact us at coreteam@neshackers.org. for any other inquiries. Yeah, so I'll be just leaving the feedback form right there so people can fill it if they want. But yeah, thanks for attending. That ends the Friday Hacks. That ends the Friday Hacks for today.